Hello everyone, this is lecture number 32. In today's lecture, we will learn how to design a trickling filter or some numerical example on a trickling filter. So content of today's lecture, you can see here. Just we will see a numerical on trickling filter by using NRC formulae, National Research Council of US, right? So there are first example which is on trickling filter. So sorry for that. Actually, we see a first example in a previous lecture. This is example number 2. So, and this example, we can see here, we have to design a high rate single stage trickling filter for treating domestic sewage flow of 8 mld using NRC formulae. Use following data. So here are first given BOD of 5 days of raw sewage are the given, that is 240 mg per liter. BOD removed during primary treatment, it is equal to near about 30%. Then organic loading rate, that are the given 0.8 kg per meter cube per day. And fourth one data are the given here, that is hydraulic loading rate is 15 meter cube per meter square per day. Recirculation ratio, that is equal to 2, and these 5 are the given, and they have said that determine a volume of filter media, second the dimension of trickling filter, and efficiency of trickling filter. So in the solution, so you can see here in the solution, first we have to write the all given data after doing all conversation. So first is the sewage flow, that is 8 mld, that is equal to 8 into 10 raised to 3 meter cube per day. Then BOD of raw sewage, that is equal to 240 mg per liter. BOD of removed during the primary treatment, that is PST, it should be equal to 30%, which is already given. Then a hydraulic loading rate, that already given 15 meter cube per meter square per day. Recirculation ratio, that is equal to 2. These are given, we have right here. The step number first, so we have to determine here first volume of filter. For determining volume of filter, first thing we required here the total BOD present in the raw sewage. Okay, so total BOD how much present in term of raw sewage, that is equal to 8 into 10 raised to 3, which is already given, multiplied by 240 into 10 raised to 6 into 10 raised to 3, that is equal to the 1920 kg per day, which will be the total BOD present in the form of the raw sewage. So second thing, total BOD present in a raw sewage. So therefore we can rewrite it at MLD, that is equal to 8 into 240 mg per liter, that will be equal to automatically 1920 kg per day. So third thing, BOD removed in PST, so that means primary settling tank, how much BOD can be removed, which already given, so that is 30%, so that 0.3 multiplied by total BOD present in the raw form, that is 1920, that is equal to 576 kg per day, which is a BOD removed in PST. So hence BOD applied to the filtered. So BOD applied to the filter, total BOD present in the raw sewage minus BOD removed in the PST. So we have got two values, 1920 minus 576, that is equal to 1344 kg per day. So therefore filter volume V is equal to total BOD to be removed divided by permissible organic loading. These are the relations have these three things: filter volume, that means the volume of the trickling filter, which is equals to total BOD to be removed, just we found out here, and divided by permissible organic loading. So 1344 kg per day divided by 0.8 kg per day per meter cube, which already uh, given here, that is equals to 1680 meter cube is the volume of the filter. So therefore we can rewrite it. So volume of filter is 1680 meter cube. So step number second, sorry, to determine the dimension of trickling filter, just we found out here in the previous slide, that is volume of filter, we know that. Now we have to find out in a dimension. Is dimension is the thing, but the diameter and its height of trickling filter, so it is called the dimension firstly. So in the second step we will find a dimension of trickling filter. The first we should know that total volume of wastewater, that is a Q, which is already given, that is at MLD, that is nothing but as 8 into 10 raised to a meter cube per day. Then total flow including the recirculation, we have the one formula, 1 plus R. The R is nothing but a recirculation, Q is a discharge of that flow. So therefore put the all values in the given formula, 1 plus 2 bracket complete into the 8 into 10 raised to 3, that is equal to 24 into 10 raised to 3 meter cube per day is the flow including recirculation. So that therefore you can write here, we know that filter area, that is, this is another relation which can be used for finding the area here. Filter of area, that is equal to total flow divided by hydraulic loading. So here we got in a previous slide, the total flow is 1344 kg per day divided by 0.8 kg per day per meter cube is the hydraulic loading, that is equal to 1680 meter cube. So therefore area is equals to 1680 meter cube. Let now the in the second step we have calculating here dimension, and you know that in the dimension of any circular sections in the sewage treatment plant, it may related to the depth, width, depth and the height. So first let D be the diameter of a filter medium, and therefore A, we know that A is equal to so we know that actual in a circular, any circular section, how to find out mathematically its area, that is A is equals to pi by d square divided by 4. So that area we found out in a previous slide, that is 1600 1600, that is equals to pi by d square by 4. Therefore, d square is equals to 1600 multiplied by 4 divided by pi, and we got here d is equals to 45.13. So nearly about nearly equal to, that is we consider it 45 meter. So next term which we have to find out here in terms of our dimensions, that is depth. So filter depth, you can see this is equals to, sorry for that, there are the double sign which I put by my help. So filter volume divided by filter area. So H is equals to, we know that filter volume, that is 1680 divided by filter area is 1600, that is equals to 1.05 meter. It will be the height of that trickling filter media. So therefore, we can write a dimension of trickling filter in this form. First, diameter of D is equals to 45 meter. Then filter depth H is equals to 1.05 meter. So these are the dimensions of a trickling filter. So already given in the numerical example, they are asked to determine the three parameter. One is what is the volume, then second dimension, and the third one the parameter which is very important, a design purpose of a trickling filter, that is the efficiency of a trickling filter. So third one step which we have to determine here, that is efficiency of a trickling filter. In the efficiency of trickling filter, we know that efficiency of trickling filter already be seen in RC formula. In a single stage trickling filter, which we have to use this formula, E2 is equals to 100 divided by 1 plus 0.44 under bracket F1 BOD divided by volume of that particular session into recirculation ratio, bracket complete raised to the 1 by 2. Otherwise, this bracket can be taken as in the under root. So F1 BOD is the total BOD applied to the filter in kg. So already we found in a say first step, that is 1600 kg, and RF1, that is a recirculation ratio R in terms of a recirculation, and we have used this formula 1 plus R divided by 1 plus 0.1 into R. Here R is a recirculation ratio, so you know that the magnitude of the R put into this particular formula. So 2 are they already given, so therefore RF1 is equals to 1 plus 2 divided by 1 plus 0.1 into 2, that is equal to 0.16 at hectare meter. So put the values of all the magnitudes in the particular formula. So F1 we have found out just here. So volume of Trickling filter, you know that RF1 also we found out here. So put the all values in this particular formula. After putting all the magnitude of particular parameter in this particular formula, we can see here E2 efficiency of that single stage Trickling filter is equals to 100 divided by 1 plus 0.44 under bracket 1600 divided by 106 680 multiplied by 0.638 bracket complete raised to the half or 1 by 2, that is equals to 78.566% is the efficiency of the trickling filter. So as per the given determination, we already found the three parameter. First parameter was the volume of trickling filter, then second one is dimension is term of height and the diameter, and last one is the efficiency of the trickling filter. If they are asked the design of any trickling filter, these three parameter which is very important, then we'll get the full marks. So in the next we can, I put here some one example for the practice. So you have to do practice solving this example. The example very simple, that is example number 3. A single filter is designed for an organic loading which is at 10,000 kg of a BOD in the raw sewage per hectare meter per day with a recirculation ratio of 1.2. So this filter treat a flow of 4 mld of raw sewage with BOD of 200 mg per liter. Use NRC formula to determine the strength of effluent BOD removed in a primary sedimentation tank is the 35%. So here again you have to use NRC formula, and by that using NRC formula you to design here a single rate trickling filter, that is in terms of what its volume, its dimension and the efficiency of a trickling filter after considering all this parameter. Okay, this is for your practice example. Already I solved it, so I don't. So anyway, you can take the practice as well as already I solved this example in here. So first you have to write the all parameter which are the given. So raw sewage flow, that is 4 mld. So you know that it should be converted to liter per day, 4 into 10 raised to 6 liter per day. Then BOD for the 5-day raw sewage, that is 200 mg per liter. Then BOD removed during the primary treatment, that is PST, it is equal to 35%. Organic loading rate of raw sewage, that is equals to 15 hectare meter per day. Recirculation ratio, that is 1.2. So step number first, to determine volume of tank, the BOD of raw sewage is equals to 4 into 10 raised to 6 into 200 into 10 raised to minus 6, which will get the BOD of raw sewage, that is 800 kg per day. Required area, that is total BOD in a raw sewage kg per day, it should be divided by permissible BOD of loading, it should be again kg per day per meter square. So here we got here After putting the all parameters of magnitude here, the 800 divided by 10,000 multiplied by 104, we got here 800 kg per day. So assuming depth of that is 1.8 meter, and we'll get the volume of the tank. So sorry for that, you have to solve this example are be mixed with the another slide. So for the practice purpose, you can use this example and solve it on your write-up pages. So due to some technical reason, it can be not supporting to online recording.